If you're watching this video, and I'm pretty sure you are, well, I'm going to hazard a guess and say that you've at least interacted with a large language model or an LLM. LLMs can quickly answer natural language questions, provide summarization, and follow complex instructions. But have you thought about the operational side of these models? LLMs need deployment, monitoring, and maintenance just like anything else. And that's what LLM Ops addresses: large language model operations. It's a collaboration of data scientists, DevOps engineers, and IT professionals in an environment for data exploration, prompt engineering, and pipeline management. LLM Ops automates the operational and monitoring tasks in the machine learning lifecycle. Ah yes, machine learning. Because LLM Ops falls within the scope of machine learning operations, it might be tempting to think of LLMs as just another model for something called ML Ops. Now, if you're not familiar, ML Ops is about streamlining the process of taking machine learning models in production and then maintaining and monitoring them. So the difference here is that LLM Ops addresses the specifics of LLM machine learning models that traditional ML Ops does not. Now, an ML Ops lifecycle might look a bit like this. So we have exploratory data analysis and some development here as one stage. Then beneath that, we have a couple of CI/CD pipelines. What's that? That's continuous integration and continuous delivery. And in fact, we would probably have one here for deployment, and we would have another one over here for actually training our model. So training CI/CD here. And then finally, this all filters into one last stage, which is effectively the monitor stage for monitoring the model. But LLMs, they introduce additional requirements over other ML models. So for example, let's consider transfer learning. And many traditional ML models are created and trained from scratch. But that's typically not the case with most LLMs. Building new LLMs from scratch, well, that would be a very expensive operation. And many LLMs actually start from an existing foundation model, and that model is then fine-tuned with new data to improve model performance in a given domain. Or consider hyperparameter tuning. In ML, hyperparameter tuning often focuses on improving metrics like accuracy. For LLMs, tuning also becomes important for reducing the cost and computational power requirements of training and inference. Another difference, that is performance metrics. Now, ML models most often have clearly defined and easy to calculate performance metrics like accuracy or AUC, that's area under curve, and an F1 score. But when evaluating LLMs, a different set of standard benchmarks and scoring are needed. Bilingual Evaluation Understudy, or BLEU, and recall-oriented understudy for gisting evaluation, I think that's right, for Rogue. These are all things that require additional consideration during implementation. So the components of LLM Ops look something like this. So at the top here, we have EDA, or exploratory data analysis, to iteratively explore and share data for use in the LLM model. That moves us in to data prep, that transforms, aggregates, and deduplicates data. We have prompt engineering, that's used to develop prompts for structured, reliable queries to LLMs. Now, as we've discussed, it's likely that this model will actually be fine-tuned to improve its performance to the domain where it's operating. There's also a model review and governance process to track the model and pipeline versions and then manage their complete lifecycle. There is model inference and serving, and that can manage the production specifics of testing and QA, such as frequency of model refresh and inference request times. And finally, an LLM Ops lifecycle is likely to include a stage for model monitoring that includes human feedback to your LLM applications. This stage can identify potential malicious attacks, model drift, and potential areas for improvement. Ultimately, LLM development consists of many components, and some of these components are specific to LLMs, not other machine learning models. And those developed LLM models need to be deployed and they need to be monitored. And all of this requires collaboration and handoffs across various teams. An LLM ops platform like this can streamline this, where data scientists and machine learning engineers and DevOps and stakeholders are able to collaborate more quickly on a unified platform. In essence, LLM ops improves things like efficiency throughout the entire life cycle. And then when it comes to risk, we can reduce the risk through improved security and privacy by using advanced enterprise-grade LLM ops to prioritize the protection of sensitive information. And LLM ops enable easier scalability, and that's through the management of the data, which is important when we're talking about multiple models that need to be overseen, controlled, and monitored for continuous integration, delivery, and deployment. So that's LLM ops in a nutshell. It's a set of practices, techniques, and tools used for the operational management of large language models in production environments. And unlike the broader ML ops, it addresses the unique approaches required to train and deploy LLMs. If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe. Thanks for watching.